In previous classes, we have already studied about the squares of numbers. A square is the number multiplied by itself. For instance, square of 3. Today we will talk about squares and square roots. A perfect square is something like take a variable n equals to m square. Now we will understand this equation with the help of an example. Like take 9. 9 equals 3 square, or 9 equals 3 into. So 9 equals 3 into 3. Hence we can conclude that a perfect square is something that is a square of any natural number. Now we can also conclude that a square is the number multiplied by itself. We can see here 3 square is the number 3 multiplied by itself, and the product is 9. Therefore, a square is a number multiplied by itself. Now, how can we tell that a number is a perfect square? So there is a method of finding out that a number is a perfect square or not. First, we need to find its prime factors. Like take a number, supposedly it is 256. So its prime factors are its prime factors are 256 is a number. Its prime factors are 2 into 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 2. So these are the prime factors. And if the prime factors occur in pairs, the number is a perfect square. We need to take out pairs. 1, 2, 3, 4. They all occur in pairs. So this number over here is a perfect square. And how do we take out that what square it is? Then we can take it as a single number. 2 into 2 equals 2 into 2 into 2 into 2. And then this number is 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. This number is the square of 16. 16 square equals 256, or root 256 equals 16. Now there are some properties regarding perfect squares. A number can be a perfect square only when the number of zeros in that square are even. If there are odd number of zeros, the number is not a perfect square. Property meaning a number can only be a perfect square if the number of zeros in that number are even. If there are odd zeros, the number will not be a perfect square. Take for instance, I'm going to phone number 250 94000 34000 So these two numbers over here have not even number of zeros. The first has one number of zeros, and this one has three number of zeros. But over here there are four number of zeros and there are four number of zeros. Hence, we can conclude that these two numbers are not perfect square. But these two numbers are perfect squares. Now, property number 2. This is a really common property. Property number 2 and property number 3 are related. A square of an even number is always even. You need to note these properties as they are very important. A square of an even number is always even. 4 square is equals to 16. 8 square equals to 64. 12 square equals 144. 2 square equals 4. All these numbers over here are even numbers, and the squares of these numbers are also even numbers. So we can conclude that the squares of even numbers are always even. Now comes the property number 3. Property number 3 says that a square of an odd number is always odd. A square of an odd number is always odd. Meaning that the square of an odd number, take for instance, we can take 3 square, will always be an odd number. Like 9. We can also take another number like 13 square, which is 169. 9 square, it is 81. All these numbers over here have their squares odd. Hence, we can conclude that a square of an odd number is always odd. The property 4 tells us that a number ending with 2, 3, 7 or 8 can never be a perfect square. So a number that ends with 2, 3, 7 or 8 can never be a perfect square. Let's take for example 82. 82 is not a perfect square. 77 is not a perfect square. 68, it is not a perfect square. Three of these numbers over here are not perfect squares. Any number that ends with 2, 3, 7 or 8 can never be a perfect square. Now comes the property number 5. Property number 5 tells us that any perfect square is either a multiple of 3 or exceeds it by 1. So this property tells us that any perfect square that is there, it is either a multiple of 3 or it exceeds 3, the multiple, by 1. We can take for example 9 square equals 81. According to the divisibility rule of 3, 8 plus 1 equals 9, and it is a multiple of 3. Then comes 12 square 144, 44819. This is also a multiple of 3. But then comes 4 square 16. This is the multiple of 3, 15, and it exceeds it by 1. As said here, it exceeds by 1. And 16 is exceeded by the multiple of 3 by 1. Now comes the property number 6. Property number 6. This property tells us that any perfect square that is extended, any perfect square is either a multiple of 4 or exceeds it by 1. This property is related to the property number 5, but the digit over here is property number 6. This property tells us about any perfect square that is perfect, is either a multiple of 4 or exceeds it by 1. This property is related to property number 5, as the property number 5 says a multiple of 3 and exceeds it by 1, but the property number 6 says either a multiple of 4 or exceeds it by 1. Any perfect square is either a multiple of 4 or exceeds it by 1. So we can take any example, like take for instance 4 square equals 16. This is a multiple of 4. And here comes 12 square equals 144. This is also a multiple of 4 or it exceeds 4 by 1. Now, 144 over here is also a multiple of 4. And we can take all those perfect squares. They are either a multiple of 4 or they exceed the multiple of 4 by 1. Now comes property number 7. This property tells us that any perfect square is a sum of consecutive odd numbers starting from the start of all natural numbers. Any perfect square is a sum of consecutive odd numbers or numbers starting from the start of natural numbers. So, according to property number 7, any perfect square is a sum of consecutive odd numbers, meaning odd numbers continuously from the start of the starting of natural numbers. Take for instance 3 square equals, so 9 equals 1 plus 3 plus 5, and these numbers are consecutive odd numbers starting from the start of natural numbers 1. We can take many examples like this. I'm showing 2 or 3 examples. 12 square equals 144. This is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. So the 12 square 144 is the sum of all the consecutive numbers starting from the number 1, or all the odd consecutive numbers. The property number 8 says that the difference between any two perfect square, any two numbers that are being squared are the sum of the two numbers. The difference between any two numbers that are being squared is the sum of the numbers itself. Like take for example, we can take 4 square minus 3 square equals 4 plus 3 equals 7. So here if we take any two numbers that are being squared, if we want to take out the difference, we can simply add those two numbers and the difference will be same. We can prove it by 4 square equals 16. 16 minus 3 square equals 9. 16 minus 9 equals 7. So, and we can take another example, 5 square minus 3 square, and this equals the sum of both the numbers. 5 plus 3 equals 8. We can solve it also. 25 minus 6. So 5 square minus 4 square equals 5 plus 4 equals 9. We can take the example, prove it as 25 square equals 25 minus 4 square equals 16. We can take it and subtract it. 5 plus 15, 1 minus 6 equals 9 equals 9. Their difference will be equal to the sum of both the numbers. If they are consecutive numbers, we need to take in mind if they are consecutive. This applies to only consecutive numbers. Consecutive numbers. Now comes the property number 9. This is more like a trick than a property. So the property is, property number 9 and 10 are both tricks to take out the square of numbers that are related to them. Property number 9 says that any number that is 1 and has all letters 1, its all digits as 1 square, it will follow a peculiar pattern. 1 square equals 1, 11 square equals 121, 111, 111 square equals 1, 2, 3, 2, 1, 2, 3, 2, 1. This pattern goes on till we can think like take a very big number. This is a very big number. We can take out its square easily. 1, 2, 3, 4, 3, 2, 1. This is a trick that applies only to numbers that have all the digits as 1. Now property number 10 says any number that is a 2 digit and it ends with 5, this trick can be applied. Take for instance 25 square. 5, we have to remember the number 25 as 5 square equals 25. We will write 25 over here. Then we will take the ones digit place and multiply it with the number after it. Like there is a one digit place in this number is 2. Then we will multiply it by 3 into 2 equals 625. Now 25 square equals 625. Then comes 75. This is a really big number, but we can take out its square easily. 5 square, 25. Then we have to multiply it with the number after it. So the number after 7 is 8. So 7 into 8 equals 56. 56.5. Now we will move on to the topic of square roots. But before that, we will do an exercise that is given in the book. We will do worksheet 1 of chapter 1, squares and square roots. So the worksheet 1's first question. Worksheet number 1's first question is, which of the following numbers are perfect square? Which of the following numbers are perfect squares? So the following numbers given here are 11, question 11, 16, 32, 36, 50, 64, and 75. Now we need to take out which of the following numbers are perfect squares. We studied a method in which we can take out numbers that are perfect square. We can figure out if this number is a perfect square or it is not. Or if it is a perfect square or it is not. So the method was to take out the prime factors and then pair the numbers, and if they occur in pairs, it will be a perfect square. So the first number over here is 11. 11. It doesn't goes by any number other than itself, and there will be 1. And 11 has only one number and it does not occur in pairs. So this will not be a perfect square. Now the next number comes 16. 16 is the square of 4. 16 is the square of 4, but it can be easily found if you learn the squares till till 10. 10 square. If you learn, you can easily do calculations. But I will do it here. 16. 16, 2, 8, 2, 4, 2, 2. And now 2 into 2 into 2 into 2. They occur in pairs. So we can take them out and it will be 2 into 2, 2 into 2. It will be 4. It is 4 square. And this number over here is a perfect square. So we will encircle it as it is a perfect square. Then comes the number 32. Now we need to tell whether 32 is a perfect square or it is not. So we will try and factorize 32 to 16 to 8 2, 4, 2, 2. 2 into 2 into 2 into 2, and these do not occur in pairs. We can take out 1, 2, but this 2 is left alone, and that's why these do not occur in pairs. So this number over here is not a perfect square. Then comes the number 36. 36. Now we need to prime factorize 36. 2, 18, 2, 9, 3, 3. Now these numbers occur in pair. So we can say that 36 is a perfect square. Then comes the number 50. Is 50 a perfect square or it is not? We can factorize it to 25, then 5, 5. And these numbers do not occur in pairs, 5 into 5, but 2 remains alone. And that's why 50 is also not a perfect square. Then comes the number 64. 64. 2, 32. 2, 16. 2, 8, 2, 4, 2, 2. Now these numbers occur in pairs. So this number over here is a perfect square. Now we need to check whether 75 is a perfect square or it is not. So we need to prime factorize 75, 5, 15, 5, 3, and 3 remains alone. And 75 also doesn't occur in pair. That 5 and 5 come in pair, but 3 remains alone. So our first question is solved. Now we move on to the next question. After this, we will discuss in the next class. Till then, stay tuned and subscribe to our channel so that you can get the next videos. And also comment in the comment section to tell me about the mistakes I made or anything that needs to be improved or the thing that looked good. Now, bye bye.